Hey, so let's talk about AMQP 1.0 ActiveMQ service virtualization, API mocking, and system simulation. So what we see is a pattern where systems are communicating using an ActiveMQ broker over AMQP 1.0 API. So system A will be sending request messages to the request queue, which are then consumed by system B. And the system B does its processing and produces those response messages on the response queue, which then can get consumed by system A again. This is the pattern. What you see in these situations is that you might have a testing issue when your team and the system B team are working in parallel. So you've defined the APIs or the format of the messages, how your systems are going to be communicating with each other, but your teams are working in parallel. So system A will be sending request messages to the request queue, but system B is not ready yet because that team's got more work to do and they can't finish that system. It's not finished yet, so you actually can't test your system A without that system B because system B is not producing any response messages. So how do you go about that? Well, you can use service virtualization, system simulation, or API mocking to generate those response messages. And the way it works is, in this case, we're going to be using traffic parrot service virtualization, and traffic parrot will be consuming those request messages. And based on the configuration we provided with, it's going to be creating the response messages. We've got a sample application for you here, the flower order system, and we'll be testing it. So I'll be testing the system under test, which is the flower order system that uses the Vertex AMQP clients to send order flower messages to the orders queue on an ActiveMQ broker over those AMQP 1.0 APIs. And the order processing system is not available yet. So I can't test my use cases for the flower ordering system because I don't see those order confirmation messages, so I can't test the whole user flow. How do we go about that with Traffic Parrot? Again, we're going to use Traffic Parrot to consume those request messages and based on the configuration we provided with to produce the order confirmation messages. And we know how those confirmation messages are supposed to look like because we've agreed on that before with that order processing team, how the format of those messages will look like and what the API looks like. So let's have a look at the order processing system first. I'll extract it here and I'll start it. And you can see it's got issues starting up. It's failing to connect to localhost port 5672. It expects an ActiveMQ broker there and there's nothing there. So we can stop this and we'll need to simulate that with Traffic Parrot. So let me extract Traffic Parrot and start it up. The first time it starts up, the antivirus kicks in, so it takes a few seconds for that to run. There it is, it's starting up. So I can go now to localhost 8080. Go to JMS, add edit, and create that simulator. So I'm going to tell Traffic Parrot to consume messages from the orders queue and produce confirmations on the confirmations queue. And I'm going to copy a sample response from the documentation because this is what we've discussed with the order processing team. The messages are going to look like. Save that and go to JMS replay. And what we'll see is Traffic Parrot in here says that any messages on the orders queue will be consumed and will be producing messages on the confirmations queue, and this is the format of those messages. Okay, so I'll go ahead and start an ActiveMQ broker on this port and let it be an AMQP interface, turn on the replay, and what I've got right now is order processing system simulator set up just like that. So we can go back to that flower order system, configure it, point it on localhost 9091, which is where Traffic Parrot is running. It's internal ActiveMQ broker. Start it. And now you can see it's running. It's consuming messages from orders and producing messages to the confirmations queue. So we can open it up. It's running on localhost 8282, and this is the flower order system. So let me order 9 roses. And there we go. I've got a confirmation that says 9 items of rose ordered. What does that mean? Well, that means I was able to test my flower order system in isolation. And how did that happen? Well, Traffic Parrot, if you look at the logs, simulated that response. So we scroll to the very bottom here, and what we'll see is the Traffic Parrot received a message on the request queue called orders. And this was the message. It was 9 or an order for 9 roses, and it's sent a message to the confirmations queue, and this was the message, the one we've configured it to send. Okay, perfect. So what we've got now is Traffic Parrot simulating the order processing system. The challenge we have though is we should take it a step further, because if I suddenly order 1 daisy, what I'm getting back is the same response from Traffic Parrot. Why is that? Well, that's because if we go back to Traffic Parrot, turn off that virtual service, look at that mapping, I've configured it to do that. It's always going to return 9 roses with this hard-coded date. So what we want to do now is make it a bit more dynamic. And the way we do that is like this. So we know this is how the response should look like. We also know this is how the request looks like. Okay, so it's got the quantity and the item you're ordering. So what we can do is use the request data in the response, and then Traffic Parrot will be generating dynamic responses. So we can tell Traffic Parrot that it's gonna extract using JSON path something from the request body. Is going to be the quantity, is going to be the order name, and the date format should be generated from now, and this is the format it will generate it in. So this is how a sample dynamic response would look like. So order item name, well, to get the order item name in the response message, look at the request message body and extract the order item name from there. Same with the quantity, and when it comes to the date, generate a date now in this format. You can copy that, paste it into Traffic Parrot response, save it, start the virtual service again. It's running. We need to restart our application. Okay, and what's going to happen now is if I order 9 roses, I get 9 roses. If I order 1 daisy, I get 1 daisy. And again, how is that possible? Well, Traffic Parrot's got a virtual service running here that takes data from the request messages and puts it into the responses. Okay, so what are the next steps here for you? We would encourage you to evaluate Traffic Parrot by going to trafficparrot.com and requesting the evaluation. And you can also download this sample flower order system and play with it by following this link. What we also offer is 4-hour service virtualization and API mocking hands-on workshops where we help you go through these steps for different protocols like HTTP, SOAP and REST, IBM-MQ, gRPC, RabbitMQ, etc., etc. We handle up to 10 people at a time, and if you're interested in that, please email us at contact@trafficparrot.com or fill in the form on trafficparrot.com, the contact form. Thank you so much for watching. Leave a thumbs up if you like this video and subscribe, and I'll talk to you soon.